Okay, wonderful. A very good morning to everyone. Namaste. Welcome back to the second day of the India Nuclear Business Platform Conference. Once again, we are delighted to be here in Mumbai for the third edition of this physical conference. Of course, before we start, we need to once again give our sincere appreciation to all our key partners, domestically and internationally. Domestically, we are delighted to be having the strong support of a Nuclear Power Corporation of India Limited. We are also grateful for our other partners and sponsors, silver sponsor, IEEE Standards Association, sponsor Asitam STUP, our exhibitors Hilti, Michelle Bearings, and Kona Cranes, of course. And we would also like to give our sincere appreciation to some of our key participant speakers who are here in attendance. Special appreciation to Mr. Sunil Ganju, Head of Institutional Collaboration from the DAE, Mr. Sunil Ganju over here. We also like to give our appreciation to Mr. N.R. Chowdhury, Executive Director of Commercial Finance from Nuclear Power Corporation of India Limited. We also like to express sincere appreciation to the presence of Mr. K.N. Babu Raj, Executive Director Finance, NPCIL, and also Mr. A.P. Samal, General Manager and Head of Nuclear from NTPC. Of course, to all our other participants, a very, very big thank you to all of you for gracing this occasion. And with that, I would like to introduce the chairperson for this session, who will be leading this session, and that's my colleague, Mr. Vinay Kanduri, who is the head of India for Nuclear Business Platform. And also one last thing, all presentations will be forwarded in PDF form to all participants after the conference. So there's no need to take pictures of the screens. That will all be given to you after the conference. And if you have any questions or whatever, feel free to reach out to myself, Zaf Quayle, or my colleague Vinay Kanduri, and we'll be more than happy to assist you in all your questions and needs. All right, with that, Vinay, the floor is yours.
Thank you, Zaf, and namaste and good morning to everyone on the day 2 of this event. Yesterday we had a very wonderful interactive sessions, and now today we are entering into the day 2 of the event, and so without going much into the words, and we would like to go straight for our session, and with the the session we would like to start with the and the session title is Transiting Away from Fossil Fuels to Nuclear. So basically this is basically a whatever the policies are being formulated in regard to the clean energy adoption in the country. The session is basically meant for that and would be addressing the issues and solutions. So we would like to have our first address on opportunities for SMRs adoption in clean energy transition. And we have with us Mr. A.P. Samal, General Manager and Head of Nuclear at NTPC. Mr. Samal, I welcome you on the podium. Please, sir.
Thank you, Vinay. Good morning, very good morning. I thank Indian INBP for giving me this opportunity to put my point of view in this forum. Today's topic is to introduce Indian power sector. They give an overview of Indian power sector apart from this nuclear. So before I go to the topic, I would like to introduce my company. I belong to NTPC. So NTPC is not new in power sector, though it is new in nuclear sector, it's not new in power sectors. So we are quite matured in as far as the power sector is concerned, electricity business is concerned. So 50% of this business we know. That means apart from the reactor, other BOP areas and electrical areas we know. So though we have to learn this nuclear business. Okay, so introducing this company, great company, NTPC. So we have a total pan-India presence, having more than 70 gigawatt of capacity under operation, and under construction also about 19 gigawatt under construction. Apart from India, we have presence, a very good presence worldwide also. solar, this renewable energy, in the whole gamut of power generation, except nuclear. As of now, we do not have any presence in nuclear sector, but very soon we are going to have this in our portfolio also. So we have about 17% of installed capacity of the total Indian installed capacity in the power sector, but we generate 23 to 24% of electricity as far as energy is concerned. So our tagline is every fourth bulb is powered by NTPC power, somewhere from the NTPC power. Every fourth bulb in India is lit by NTPC. So as you see, we have all the total sources of power generation, thermal, though it is predominantly thermal, but our future is, you can see, that includes nuclear, that includes RE, everything, and we have a target of 60 gigawatt renewable energy addition. So we are already 2.5 gigawatt approximately, and many projects are under construction. So next, yeah. So you can see the whole gamut where our presence is there, starting from carbon capture, hydrogen, the future of energy, coal mining. We have both forward integration as well as backward integration as far as power generation is concerned. And our strength, definitely, our strength is, apart from this financial, of course, we have a strong manpower. So that is the key for success of any company, this dedicated manpower, dedicated engineers, which can take forward the business. This is our core values. I want to highlight two aspects of these core values. The number one is quality and safety, which is the requirement for a nuclear energy. So we have a lot of, participants might be knowing, we have a very strong quality control system, quality systems in NTPC already existing. Only adopting the nuclear business to this fold, that is the only change we have to do as far as quality and safety is concerned. And the number two is the learning. So we are a learning organization, though we have a very matured maturity in power sector, but still we are learning. So that never stops. Now, this is our journey as far as the efficiency is concerned. This NTPC is very much, as far as the environment is concerned, starting from old days, 200 megawatt era, to till at present ultra supercritical technology, and its future is AUSC. We are also part of advanced ultra supercritical technology, that is first of a kind, having more than 710 degrees centigrade temperature and 310 ATA pressure. That is the best heat rate, best efficiency we can get from a thermal sector in operating in a Rankine cycle. That is also the future. This is some of the milestones of NTPC, starting from 1982, the first unit of Singrauli. We added to this capacity of NTPC. That plant is still operating, and its performance is much above the the newer plants. Let's say 20-year-old plant. This plant is about 40 years, 42 years old, but still operating at a better performance, giving a better performance than many of the plants. So now the last one is RE capacity. We have crossed 2 gigawatt in 2022 itself, this year itself, 2 gigawatt, and we have a plan to make it to 60 gigawatt. So coming to the Indian power sector, this if you see from the independence, 1947 till date, how this Indian power sector is growing from both thermal as well as, of course, it is mostly dominated by thermal capacity, but last 4 or 5 years or 7 years, you can see the green line, the addition of renewable energy into this sector. And if you see the thermal sector, predominantly it is coal. dominated by coal and gas. You know, Indian gas power plant is not much. We do not have many gas supplies. So mostly we rely on coal. And similarly, renewable, that also includes hydro. So total gamut of this Indian power sector having about 400 gigawatt of capacity as of now. That includes nuclear. You can see the nuclear capacity is only 2 to 3%, not much, not more than what. But we aim to increase this capacity so that this thermal capacity will slightly, slowly, it has to go to reduce, and the nuclear capacity has to increase so that the clean energy can be generated. Now, this is the energy. In terms of energy, that is the installed capacity. In terms of energy, if you see, though the capacity is 40%, renewable capacity is 40%, it doesn't operate into that capacity factors as the thermal sectors. So still we are at about 70%, 75% of energy comes from the thermal, from the fossil fuels. But if you see what is our aim from 2002 to 2022, in a time of 2 decades, about 2 decades, this has reduced from 81% to 75% as far as energy is concerned. That is not much progress. But now from 22 to 30, within a span of 8 years, we aim to reduce that to 40% about this energy, as far as energy term is concerned. If you go to the right side, this share of electricity from the total energy consumption, this is at present level, it is about 16-17% only. So other about 80% energy comes is not through electricity, that is through other means like your fossil coal, petroleum, and all those things. But if you go, the target, if you see 1950, the scenario in 1950, the energy demand is projected to be about 15,000 gigawatt, 15,000 trillion watt hour. And the electricity, share of electricity will be about 6,500 billion units. That is same trillion terawatt hour. So the share of electricity is going to increase by about 42%. So that means the energy sources, like the majority of it takes by the transport. Since transport is going to shift to electricity. Industrial sector is also going to shift to electricity. So this sector has to be strengthened. The electricity sector has to be strengthened in order to have a clean energy source. This has to shift to electricity. This is the projection of Indian energy sector. Now, this coming to this climate change. So where from this carbon comes? About, if you see, 75% of this carbon footprint is from energy sector only. So to meet this net zero targets, so the energy sector is to be cleaned. This carbon footprint from the energy sector is to be reduced. So without reduction of this energy sector, it's not possible to meet this net zero targets. So what is the options we have to clean this sector, energy sector? Let us see. So coming to this thermal capacity, we have about 231 gigawatt of fossil fuel generation capacity. Out of this total 407 gigawatt, we have 231 gigawatt of fossil fuel generations. And this, you can see the age profile of the thermal power plant, starting from 200 megawatts. Some units are also below 200 megawatt. They are also operating since maybe 40 years, more than 40 years of life. And these, some of the power plants already have been retired. So they have lived their life and they have retired. And also this, units which are already operating and have completed their useful life, they are also going to retire. But only age criteria is not to be, only age should not be the criteria for retirement of the units. What else? As I said, the Singrauli unit, 40 years old, but still it is operating much better than a new unit. So apart from age, the performance has to be the key also. Can I click that scanner one? ये वाला हाँ, हाँ, हाँ. No. So the apart from this age, the performance has to be the criteria for deciding the which plants to be retired when. So if you see, these are the age criteria of a subcritical units. Of course, the supercritical units, they operate in a much better performance level, much better efficiency than these subcritical units. If you see the heat rates, these are the heat rates of operating power plants. So all India average. If you see this, some of the units are operating at a very bad shape. They are in a very bad shape. The figures at the top, they say that gives the performance level of NTPC stations. That's average NTPC stations. So if you see the even 30, 40-year-old plant that is operating at about 2300, 2400 range. So which is much better than some of the new plants. So apart from what I mean is, apart from this aging criteria, the performance criteria should be also the deciding criteria which plant is to be retired when. No, go back. Huh. Yeah, so if I go by age only, then what I am finding, so about in 2050, at about 2050 scenario, it will be about 71 gigawatt of the capacity is to be retired. If I say the normal life is 50 years, normally the plants are designed for 25 years. Thermal power plants are designed for 25 years, but we operate it beyond its useful life also. If I go by 50 years with two interventions, two R&M interventions, then at least 70 gigawatt of the thermal power plants has to be retired. If I go by accelerated aging, because of this renewable energy, these units, thermal units, are operating in a flexible regime. When you operate a thermal power plant in a flexible regime, that means you are consuming more life of those plants. So that is what I call accelerated aging. So that will give you 118 gigawatt has to retire from the total KT of thermal power plants. Now the right hand side says the performance only, present performance. If I go, I set a target heat rate of 2600 kilocalories. Plants operating more than 2600 kilocalories as of now. It is not 2050 criteria. Then 60 gigawatt of the capacity has to retire as of now. If it is 2700, then 50 gigawatt. If it is 2800, it is 35 gigawatt. So this is the operating level, the performance level of the power plants. So at least as of now also, we have a opportunity to retire 60 gigawatt of thermal capacity. So that gap is to be filled by whom? Let us see the scenario in 2050. In the 2050 scenario, the energy requirement is 15, the electricity requirement, the demand is projected to be 6,500 billion units. And if I be very optimistic and I harness all the potentials of renewable energy in India, then that is going to be about 4,500, 4,400 billion units, not more than that, being very optimistic also. So the gap is huge. About 1,500 billion units, there is a gap. So who will fill this gap? Either thermal or any other clean sources. So hydro, we have already explored, wind and your solar, that already been explored to the maximum capacity, maximum extent possible. So remaining 1,500 billion units is the gap to be filled, none other than nuclear. That is the only option we have in order to make it net zero. Whether this is possible or not, that is a question mark. Whether we can, to fill up this gap, 1,500 billion units, how much capacity addition is required? 200 gigawatt of capacity addition is required from nuclear sector. Yesterday, Dr. Kakodkar was telling a couple of thousand gigawatt. So I'm not talking about couple of thousand gigawatt, but at least 200 gigawatt capacity if you add by 2050. So is it possible with the present framework, present conditions? I have a doubt. So we need to change our mindset. We need to change. Otherwise, what you do? Leave without power. We have seen what has happened in the recent past, even in Europe, even in India, what has happened. We have seen. So what is the option now I have in order to fill this gap? Let's say we have about, I said 60 gigawatt to be very, very pessimistic approach. 60 gigawatt is to be retired. To be in the higher side, it is a 120 gigawatt of thermal power is to be retired. So what are the options available with me to fill this gap? To utilize this, at least the infrastructure I have, what is the options I have? If you see, compare all those options, this nuclear dominates, the bottom one is the nuclear one. Nuclear dominates this. If you see the green ticks, this higher in this nuclear sector. So others like solar, wind, they can just 10 gigawatt, 2 gigawatt. You're retiring 120 gigawatt, but you have an opportunity of only 10 gigawatt or 2 gigawatt. Similarly, coal, there is a option also. So I don't know whether we will be able to, at 2050 scenario, we will be able to sustain this grid without coal. Still I have a doubt. But of course, we can reduce the carbon footprint from the coal itself by the CCUS and some other technology. I have one option also. I'll show this option in 2-3 minutes. So what can be done? So that should be a combination of both the energy sources. So now coming to nuclear, then if I fill this gap through nuclear sources, then I have two options. One is the large capacity reactors, whatever we have present now. The other one is the small modular reactors, what the today's topic is. Let us see what happens. Now, if I go for a large capacity reactors, now 200 gigawatt of capacity, and we have about 45 gigawatt either under construction or operation taken together, all taken together, it is about 45 gigawatt. So the gap is 155 or 150 gigawatt, roughly it is 150 gigawatt. Then which 150 gigawatt, I need about 40 sites, minimum 40 sites I need in India to build this 150 gigawatt. Can I get this number of sites, 40 sites, for this nuclear installation of large capacity nuclear power plants with present conditions, whatever we have, the present regulatory conditions, present requirement, all those things, can I get this? It's next to impossible to get 40 sites having to bridge the gap. So we have to change maybe the conditions, maybe the requirements, all those things we have to change. First of all, the mindset is to change towards nuclear. The other option is, of course, SMR. There is also a question mark whether this SMR meets my requirement. Whatever retired thermal power plants I have, maybe we talk about 1 kilometer this exclusion zone, whether I'll get that 1 kilometer, I have a doubt. Most of the plants will not meet the requirement. Maybe we get 500 meters, 600 meters, all those things you have to see. Really, you have to look into it, whether I'll be able to do it or not. But of course, I have a possibility, I have a potential to add about 135 gigawatt, considering only 50% of the available sites. My retirement site total, if you see, if I take 50% is not suitable, only 50% it is suitable, then I have a potential of 135 gigawatt in terms of SMR. So I am retiring about 150 gigawatt and have a potential only through these sites, utilizing these sites, 135 gigawatt. And second thing, what is the most of the infrastructure facilities can be utilized, like buildings, offices, land, roads, of course the colony, all those things can be utilized. That your cost can also be reduced. So these are some of the things which you can will be able to use of the existing facilities. Most of the problems we face in a nuclear power plant is the land acquisition. So it takes years. It takes years to clear this, to get the land in your possession. Forget about, then you start your activity once the land is in your possession. So that problem will not be there if your SMR or the design meets the criteria which is the requirement of the site. So I have to find the other way around. Don't find a site to install the nuclear power plant. Find a nuclear reactor which suits my requirement, the site requirement. That is the call of the day. Now, it is not possible to completely eliminate the coal stations very soon. Maybe 5 decades down the line, yeah, it may be possible. But we have to have it concrete plan of transition, how to transit this energy. That means how best we can reduce the carbon footprint. Even with the coal, we call it a blue coal power stations. That means bringing down the carbon footprint to level of a gas or maybe below the gas level. So if I take this system, then I can integrate a nuclear reactor, small modular reactor into my existing coal stations. So that way, biomass already it is known as a clean energy, clean source, green energy. Then of course, if you say I capture carbon dioxide, carbon capture for 100% is not possible. That is not technically feasible. As in the present technological level, it is not possible to capture 100% of carbon dioxide. If you want to utilize it, then you may need much more energy than what you generate at this point in time. Taking the power required for production of hydrogen, then any other chemicals, or for that matter, methanol also. So you need much more power than what you generate. So I propose about 20% of carbon capture and 20% from biomass, 20% from this SMR. So you reduce 60% carbon footprint even with the present coal conditions, and you get a flexible power source also. Second thing is flexibility of a nuclear power plant. As of now, it is not there. So this has to operate near about 100%. Then how it will support the renewable sources, which is always variable. So that also a question mark. Now everybody is talking about hydrogen. So we are heavily relying on hydrogen technology to make this power sector clean with the help of nuclear. This is only, I mean, taking forward this backups. If the hydrogen technology doesn't pick that much what we need, but our energy demand has to grow, then what we will do? So all those things can be, this system can be utilized to meet both the requirement of flexibility, reducing the carbon footprint as an intermediate solution. The third one is, of course, this hydrogen generation. So if the transport sector is to shift towards this hydrogen powered vehicles, then this SMRs can also be utilized for production of hydrogen. You can utilize we have lot of islands available in India. So in there you can, of course, if it is nearer to the mainland, then you can have a cable connection and have a power. But if it is away from the mainland, then this is one of the options, could be one of the options, generation of hydrogen and then transport that hydrogen to the mainland. Here we have a lot of opportunity on this also. I have roughly calculated about 100 gigawatt of capacity is available, potential is available to have these SMRs. Now the fourth aspect is the industrial heating. So about in 2050 scenario, you have about 40% from the electricity energy requirement and 60% again we depend on fossil fuel in heating. So that industrial heating can also be shifted to your SMRs. So there is huge potential to use, you see, what you are doing in a nuclear reactor, generating heat, then converting this heat again to power through a Rankine cycle, modified Rankine cycle. Why can't we use directly this heat wherever is required? So industrial heating can also be shifted to SMRs. We have a lot of potential. All those sectors, industrial sectors, can be decarbonized also. There is a huge potential also. And coming to NTPC nuclear venture, what we are trying to do. So we are trying to have a multifarious approach towards this. We want to have a big presence in this sector. Though we are learning now, new to this sector, but we have a big plan to enter into this sector. So with already we are in association with Nuclear Power Corporation Limited. We have already a joint venture company and pursuing some of the projects of PSWR technology, SMR, of course, LWR, and also we know this back-end loading fuel requirement has to be met. We are also in discussion with UCIL, DAE for arranging this fuel for this either SMR, PSWR, or PWR, whatever. So all the 3-4 technology area. So we are trying to enter into this simultaneously to make our presence in a better way. So this I have already told. There is a joint venture company with NPCIL. So we are in close discussion and pursuing some of the pre-project activities also in PSWR technology. And as far as SMR is concerned, we have two approaches. One approach is development, Indian development of the SMR technology. The other one is adoption of technology. So we are already discussing with DAE, government officials, how to go about it. We have we are also discussing with BRC for development of Indian SMR. So both the ways we are trying to have. Future is, I don't know what will happen and which way we will go. Both way we are trying, and because there are huge potential of adopting this SMRs, as I said, 2, 3, 4 areas where this can be utilized. So this is my concluding slide. So nuclear is the future of power sector. So this is going to bridge the gap between the demand and the supply for a low carbon source of power. Thank you.
If there are any questions, yeah, please. Mr. Saman is there. Mike.
Thank you, Mr. Samal, for this fantastic presentation. And for the first time, you hear somebody who is very well rooted in the fossil fuel market is trying to acknowledge that nuclear is the future. So thanks a lot for all that. I have a couple of questions. First one is, are you thinking in terms of using hydrogen to fire the fossil fuel plants? The second, should I tell all the questions and then you could choose in what sequence you'd like to answer? The second question is, have you done the cost considerations when you're trying to bring in SMR, particularly SMR for heating purposes? Third question is that what will be your business model for doing SMR? If we can understand your business model probably for the 700 megawatts, but what could be the potential business model for doing the SMRs? So these are the three questions. Probably you could choose which sequence you could like to answer. Thank you so much.
Yeah, I'll answer your first question first. Firing hydrogen in fossil fuel plants, the answer is yes. So we have already have a MOU with this gas turbine manufacturers, GE. So to fire this hydrogen in the gas turbines first. So we have not tried yet in a thermal, coal stations. So that is distant dream. So we are trying to fire hydrogen in our gas-fired power stations. So in near future, we'll have a declaration also, the success of this story. What is your second question?
Well, have you taken the cost consideration for using SMRs for the heating purposes?
Cost for the you see, the cost of SMR is not known as of now. There is no SMR operating in worldwide, if you see, except maybe some say Russia and all those things. That also cost is not known. So it is very difficult to say at this point in time what will be the cost of this generating up. But definitely, as yesterday also you have seen, there is a misconception that nuclear energy is costlier. For me, it is not costlier at all. If you see the lifetime cost, it is comparable to any other source of energy, and sometimes it is cheaper also. I don't think it is costlier. You see in a solar plant, you say what is the cost? 2 rupees, in the order of 2 rupees. That's the minimum we get in India, 2 rupees. But how many hours in a day? How many hours? So if you want, there is a concept called RT, round the clock RE, RTC RE. What is the cost of that? If you add the storage technology, cost of storage technology, what will be the cost? It is never 2 rupees. It will be much more than what a nuclear power plant gives you round the clock energy. That is also clean. This is also clean. At the same time, I should say it's not as cleaner. You have seen yesterday also the lifetime carbon dioxide emission. In a solar panel is much higher than nuclear. So it is not costlier. Similar way, if you go for a mass scale of the self, we are talking about SMR and maybe thousands of SMR installations to meet this requirement, then the cost will be much less than your some other form of energy. So it is really very difficult to predict as of now what will be the cost. We have to see. Then your third question was the business model. Business model. Really, I cannot divulge more details on this, how we are going to have this SMR business. We are under discussion, both way.
Okay. I just want to inform you that the flexible power operation, if you look at the US plants, at least in the deregulated markets, the states where the the energy market is deregulated, most of the plants are moving into a thing called FPOs, flexible power operations. So as Westinghouse, we have been able to convert these plants, which were earlier considered as a base loads plants, to a flexi power operations plants. And there are many, and those heats also could be utilized from those plants for heating purposes. And apart from that, we also have something like an electrothermal storage facilities, which could support about 25 megawatts to 100 megawatts to convert the renewables into 24/7. So if you think that NTPC could be a good market or there could be mutual interest, probably we could talk off the line. Thank you so much.
Yeah. As far as flexibility is concerned, you see in Indian power sector, NTPC is the only utility who is operating the thermal power plants in a flexible way to support the grid. There are many initiatives taken by NTPC to support this grid and increase the ramp rate of our power plants to the order of even 3% per minute. 3% per minute ramp rate we have already achieved. And some of our plants are operating in load following mode, completely independent, directly taking command from the dispatch centers. So they're operating. So as far as storage is concerned, we have not started the storage of thermal storage, or of course we have started some battery storage applications through this solar, but we are yet to start thermal storage activities. But that, I think that is not required in power. If you see the size of the grid in India and the size of the RE power as of now, it is not required. Thermal storage.
The deficiencies in RE is to make it 24/7. So if you have a thermal storage, probably you could make it 24/7. And one has to look at it, what will be the return trip efficiencies, so that you could see that whether this RE as converted to 24/7 by a good thermal storage facilities could be cost competitive with the prevailing prices.
Mm-hmm. I think there are some other options also for storage.
There are several options, yeah. But thing is that probably one of the most cost competitive could be thermal storage. That's
I
what-
have a doubt. I have a doubt.
That's
I have
what-
seen some presentations of thermal showing thermal storage. You see, you know
Well,
this.
I would not like to get into the debate over here now on
Yeah,
that.
exactly,
But
exactly.
we could exchange the informations which we have of the lines. And the FPOs which I was talking about was mostly for nuclears. So we have that capabilities, and that mostly the modern plants of future generations will be all on FPOs, nuclear power plants. Thank you.
I can give only one argument on this. Going to thermal, from electricity to thermal, you know that is easier. But thermal to electricity, how much efficiency you get? 30%, the order of 30%, 35%, not more than that, maximum 40%.
I just wanted to mention that it all depends on the return trip efficiency. So let us look at the return trip efficiency for a lithium batteries to a thermal storage system. Thank you.
Yes, sir.
I think there is a lot of hype about SMRs in the present scenario. You know, any technology for it to be commercially viable, I mean, we have many cases, takes roughly about 30 to 50 years of maturity period. And here we have a case where the design itself is not known. Like yesterday, Vice Admiral Nadaf also said, that first let us at least decide the design. And you yourself are conceding that there is only one SMR presently working in the total world, and that to 2 into 30 KT-40 in Eastern Russia. So it looks to me a case of very eager parents looking for a bridegroom, booking the hall, booking the caterer, everybody, but Dula is not known. The bridegroom is not known. So we are, I mean, at that stage. So we have to have the 3D model. 3D model, I mean, development, demonstration, and deployment. Unless we go through these 3Ds, SMR is very, very distant future. Thank you.
Right, sir. So, sir, I have already shown if I want to bridge this gap, I need 40 sites. For the larger capacity reactors, I need 40 sites. So I didn't say it is only SMR is the only the option. SMR is one of the options to utilize these vacated power plants, whatever it is there. Because at these present conditions, present regulatory requirements, I cannot have large capacity reactors installed in my vacated thermal power plant. That's for sure. Maybe even 1 or 2 sites, if it is becomes suitable for installing a 700 megawatt reactor, I'll be very happy to do that. So there are two channels, both large capacity reactors as well as possibility of SMRs, installing SMRs. Of course, SMRs maybe 6 years, 7 years, 10 years down the line, it may be ready. The technology may get matured. I do not know really. You are absolutely right. Any technology to get matured, it takes 20 years, 25 years, 30 years. Absolutely right. So we have to see which way we have to go.
Okay, I have a question. First of all, very nice presentation, Mr. Samar. You said 40 site. I understand you are talking about addition of 150 gigawatt. So if you consider nuclear park like Jaitapur, so each site corresponds to something around 10 gigawatt. So if you'll go for a nuclear park concept, then you will require something around 15 to 20 new sites. This is point number one. This is my observation. The second one, even if let us take technology matures very soon for the SMR, and I understand that SMR would be something around 300, 400 megawatt. So if you want, then what is the capacity? Then? Okay, so let us take it as 300. Understood, sir, but assume that it is 300. Okay, so he is saying it is less than 300. So if it is 100, and if you want to add, let us take your aging plant 60 gigawatt right now. So if it is 100, then you require 600 SMR, even for your current 60 gigawatt. So in my opinion, you as rightly said that a mix of nuclear park and exploring the SMR, that would be in my opinion, it would be a more prudent strategy rather than only talking about the SMR. Even say 700 megawatt, which is the latest PSWR 100% indigenous. If that capacity can be enhanced by again revisiting the design, and again with even for the Indian plant, if we are going for say nuclear park concept, maybe the number of site will be less. And the second one is that out of say you said that 60 gigawatt, but 60 gigawatt will maybe there would be some site which are not in the city. It is remotely located. So out of say 60 gigawatt are retiring, you would have at least some 8-10 site. So out of 8-10 site, even if 3-4 a few site can be suitable for the nuclear, then we will have again the less number of site for new site for the capacity addition. Okay, thank you. This is what I wanted to add.
Yeah, I absolutely, you are correct. So there will be a combination of large capacity reactors as well as small modular reactors. When this reactor, SMRs, as sir said, this technology matures and it is available for installation in a mass scale, large scale. That is absolutely correct. There is no doubt about, no debate about it. As far as number of sites is concerned, you cannot get sites like Jaitapur everywhere. So there will be, that is an average requirement, average number of, let's say, if you say, take 5 gigawatt in one site 5 gigawatt or 4 gigawatt. I have taken 4 gigawatt. So 150 gigawatt, 4 in a place. So about 40 sites, that's what the statistics are given. Coming to the existing thermal power plants having number of SMRs or large capacity reactors in a thermal power plant. I have mapped all the thermal power sites, existing sites to the requirement of a large capacity reactors. Hardly I get 1 or 2 site which meets this requirement. Because number one, in when you have mostly the thermal power plants are at pithead stations near the coal mines, and once you have a power plant, there are a lot of population develops. There are a lot of opportunity for the people livelihood. So they settle there in and around the power plants. If you see anywhere you go, in a nuclear power plant, it is not allowed, but in thermal power plant, because of the development, it is allowed. So you'll get a lot of population near the power plant. So that may not be suitable for having a large capacity nuclear power plant. Of course, 1 or 2 sites may be possible, or we have to see how many sites will be suitable for to have a large capacity power plants. Really, you have to see.
Actually, I was listening to many of these questions, comments, but I don't have any questions, comment. I'm trying to answer on your behalf. One is what Dr. Mishra was asking, many questions. Let me tell you, like levelized cost of electricity, LCOE, similarly, levelized cost of heat. Nuclear reactors, especially you talk about SMRs, one of the target is to produce heat for number of applications, which includes something what Mr. Samal also spoke out, as a heat source for process and chemical industries, not only for electricity production. Today, I will say that large fraction of energy is utilized in form of coal or other forms to produce heat for these industries. So LCOS will be much more, I'll be cheaper as compared to electricity, because as he rightly said, the efficiency goes down to 30% the moment you convert heat to electricity. But if you use heat, it is much cheaper as compared to even you go for renewables. That is strategy one, which you could not speak out, but it is also what other countries are looking at. Second part, there is, I think, big misnomer that SMR is the replacement to large reactor. No, it is not replacement. But our basket is too big and our country is too small. This yesterday also I was speaking. We are a small country with 140 crore population today. Another 30 crore is going to be added, 170 crore population. Yesterday, if I heard to Dr. Kakorkar, he was speaking that we need 2,500 gigawatt electric from nuclear. Forget about other sources. And as Mr. Samal said, if 700 megawatt PSWR or 1000 megawatt even PWRs we put, how many we can put in India to meet 2,500 gigawatt? Maybe it will not be much more than few hundred gigawatt because sites are limited. That's all. So he is putting a bigger opportunity that the retiring something he said as on today it gives opportunity to something like 60, 70 gigawatt. Even we ourselves have done these estimates, more than 150 to 200 gigawatt is possible the moment we compromise on the exclusion zone. And why 100 megawatt electric? Because you are dragging to 300 megawatt electric. 100 megawatt electric is that size if with all passive system in place, there is no impact in the public domain. In the sense, the SMR can be located in a city like Mumbai, which is not possible to put it by large size reactors. So that is why the size and safety systems are very important, which is not feasible in 700 megawatt or 1000 megawatt PWRs. Let me finish. So that is why the size of the reactor is very, very limited. The safety systems are predetermined, which are not possible in large size reactors. In view of this, as you rightly said, number of reactors are large, so volume is large. More you have large number of volume, the cost comes down. That's why it becomes competitive. No more question. Because otherwise, I understand because you people have not gone into SMR. SMR is not a replacement to large. There is no point in putting an SMR for a Jaitapur site. It is not an answer. Jaitapur site will have its own reactors. SMR today people are targeting exclusively for replacement of coal-fired plants, which is not feasible by large size reactors. Just let me list it. If we can put a large size reactor in a retiring coal plant, there is no point in putting an SMR there. And for your, I think something back you spoke out that where SMRs can be also sited. This work has been done in collaboration with NIAS. What they have done, even in India, there are some green sites which are not good for large size reactors, but the SMR parks can be built of the order of 10 to 15 gigawatt. That is also has been identified. So what I want to conclude that as also there were comment today SMR technology, where it is operational, this is a big question. Where was, if you look at the history of nuclear reactors, where was the 700 megawatt, 1000 megawatt PWRs? It was never there. Initially, there were only small reactors. But in 20 years, large size reactors, yesterday I was talking about, 400 reactors were built in a span of 20 years. So today also, I believe SMR technology is not new. It is a PWR technology, which is operational. Only the size has been reduced with many passive systems in place. That's all. So it is not a new technology or new invention or new discovery. Nothing is there. It is an old technology modification to suit to retiring coal plants. Thank you.
I just want to ask this thing. So can we use SMR as a captive plant for our industry? Whether this is permissible?
Yeah, it is possible. All depends upon
So
your requirements.
in that case, that SMR can be open to the usual industry who are making their captive plant.
Sir, already shown the heating sources.
So rather than going company like NTPC or NPCIL going for SMR, we should rope in the very small manufacturing and steel making industry and other industry. That would be more appropriate rather than we going and pursuing very hard for the SMR. Definitely, if some of your site can accommodate SMR, that is fair enough. But we should pursue more towards the larger reactors. This is, again, I'm sorry, let us conclude it here. Thank you.
Yeah, thank you.
Thank you very much for such a wonderful discussion. We understand there were many questions coming in that, but in the interest of time, we are really sorry for that because some of other interesting discussions are also lined up, and then we will be having some panel discussions also. So, Samal sir, thank you very much for such a in-depth analysis and such a, the concrete sort of plan that you are having for going into nuclear. Not only SMR, SMR has its own limited, adoption, opportunities. But NTPC is also going in a big way for and exploring large reactors also, as we understand from your presentation. So now moving to our next address, we have with us youth who are really interested about the nuclear sector, and we want when they approached us, we really think that we should be giving opportunity to our youth to basically come forward and have their say in front of industry, what they are looking for, what they are expecting from the industry. So with us we have Nitendra Singh, President of Indian Youth Nuclear Society, but unfortunately because of some health issues he couldn't join in. He has nominated his representative, and he will be speaking on expectations of young professionals from nuclear establishment and policymaker. Mr. Samyak Monath, please welcome.
Morning, everyone. Dr. Nitendra Singh has already apologized for not being here in person, but as sir said, due to some emergency, he was unable to hear. So, on behalf of youth, I'll try to represent the youth here on this behalf. So, I am representing Indian Youth Nuclear Society. Basically, I will start with one of the famous quote by Dr. Homi Bhabha. My success will not depend on what A or B thinks of me. My success will be what I make of my work. So that is what the intent we are trying to hear, because we perceive nuclear, and see that how the perception of the nuclear will change in the future, and how that will be required to do so in every aspect, not just industry, not just power, and so on and so forth. The imagination what I have in the perception of like how can I use nuclear will actually give me the idea of how nuclear can be changed or can be adopted suitably for those purposes. So basically, who are we? We are basically with a group of like-minded peoples who think that nuclear self-reliance will be the most prominent, factor for sustainable development in this particular domain. So let's start look here for the one matter was the rationale for using nuclear. From yesterday, we have multiple people talking about that rationale has been defined. Why nuclear, energy density, different requirements, and so different technologies has been brought out. But the similar with along with that, there are one more thing which people here are there are one point was missing, was the basically the involvement and the requirement of the youth what we are expecting. Today here we as a business development or the industrial partners all are here at the topmost positions here. But then the requirement of what the youth needs to be done, or the following upcoming fourth youths are to be there, or what are the views of using, what are the views of the youth that in link to the nuclear or the future developments is been missed out. I think that has been missed out here in sense. So basically, we are a group of nuclear enthusiasts. We have formed a group under the guidance of Dr. R.B. Grover and Bharadwaj sir, S.A. Bharadwaj sir. So we are mostly initially we started with an outreach program where we have conducted the different talking about the people about the nuclear awareness programs and what are the perceptions. Today we have registered 500 members are in with us, so who contribute to the outreach program, who contribute to the development of the technologies as well, climate awareness, innovations, and what can be done as a some conceptual designs, some the looking towards the what future can give us or what we can give to the future things. So we are expectations of young generations. What we are in perception, I'll try to present here. Looking towards the Indian perspective of nuclear challenges, as we said, as there is a huge requirement of trained manpower operations. We have talked about like we want to have multiple reactors, thousands of numbers, 600, 700. All the discussion was just before that. But then we also need the equivalent number of trained people who can operate it, who can manufacture it, who can license it. one organization, multiple designs, and who doing one thing will definitely require maximum amount of time. But if they have help, if they have different people working, if they have the man force, this can be very rapidly adopted and can give us the timeline of what we are saying can be reduced drastically, working in parallel processing. And that requires the involvement of youth in a larger amount. Secondly, localization and rapid multiplication we are talking about. Localization is okay. We talk about localization is a benefit here. But then do we have that much of manpower who can localize? Can I, today I have, yesterday we talk about, how many industries are there that can produce the necessity requirements for nuclear? Electronics, mechanical manufacturing, other than transports, other various auxiliary components, there are multiple things present. But then there are only couple of industries which are able to do so. Can we go beyond that? Because since the number is so high, the time is so low, we have to have parallel working, many people playing together or a parallel setups. So do we have that much kind of this thing? And the appropriate consultations are again required. Today, what needs to be done, in which manner, what are the requirements? Having an industry said that I have excellence in some particular part, but then can I use it in the nuclear? What are the ways, what are the pathways that needs to be followed, what are the exact regulations that needs to be considered? So that also needs a proper consultations and technology development for efficient systems. That means what we are talking about, we are saying that the SMRs are there, but what we have also considered is that the standard pathways, like as sir said, the efficiency when converting to thermal to electricity goes to 30%. Can we develop more systems which can increase the efficiency? Then this will by default increase our output. So those technologies or direct application, as the point was rightly raised, can we use the heat directly for applications where heat is required? That is reducing, that will be reducing our losses. So those things, that efficient development, that technology, and a group of people or experts or that particular efficient people is also required, and that is expected from the forthcoming youth. What the innovations need to be done in that particular manner. So what as opportunity when we say the growth and opportunities. So this currently if we can look about what are the opportunities and part today. So nuclear industry is majorly currently, as we can say, that was majorly governed by DAE. We so the experts and the all the heads which or the brains which are coming from are majorly controlled by DAE. So if we there are some companies which some provide consultations like Capgemini and so, but there are very couple of them, or very small number as expected to the level of development which we want, what are the deployment which we want, and are the numbers which, so we have to have a huge number. Similarly, currently I'll just give you one rational number what I'm trying to say about. Today we are producing only 2% of electricity from nuclear. We are saying that by coming 2040, 2050, we want to have maximum number. So today, consider that NPCIL has some, the number of NPCIL, BRC, ERB, collectively are producing only 2%. So now if we multiply by that number by hundreds of thousands of reactors, we'll require the same amount of excellence, same amount of efficient, standard or skilled people to operate, to monitor, to visualize those particular part. So that opportunities will, I think, will be rising only by involving many industries together. Be it private, be it different. Such a large expansion will definitely require other culture. So similarly, I'll just tell you one thing. ISRO have we can take an example of ISRO. Today, startups on ISRO are actually launching the many ventures there, and they are successful. The similar kind of a strategy should also be involved, and that will require a good consultancy firm where we can also have nominate what we can do. So keeping that example into the mind, we need to work in those particular fashion as well. So using that as an example, we need to develop that culture, like startup culture, or involving private MSMEs and all together to make this thing happen, and a bigger vision. I know that the development time, the people what are saying that the technology is reliable or so, but we have to understand that we are in a phase of revolution. We have less time that is to be done. We know that our output is the end. We have to use this much. So drawing a straight line between 2 points is easier now. We know that we have only certain 2 to 3 decades, as sir mentioned, that before the climate change, what they have given is a 2 to 3 decades. We know we have to have a huge number of 2000 gigawatt or 2500 gigawatt electricity required. So as those points need to match, and the technology should be adopted, changed accordingly. This change will be done by technology, but then similarly the youth needs to be trained accordingly, chosen accordingly, and the technology also, they have to be given the future objective of developing efficient technologies accordingly in the particular domains as well. So what do we offer here as a youth part? We are going to soon come up with a IYNS tech solutions, because since we have expectations, it is expected that the youths will be take huge parts in deployment, in manufacturing, in having those basically keeping the nuclear into the place will be required involvement from all the sectors. So, and similarly, talking about tie-ups with MSMEs, for localization, it is said that the cost will come down to 30 to 40% by default if the parts are made in our own localized manner. Similarly, there are also there was one example of the opportunities. Standard parts are used. Commercially, what happened is some designs require a specific type of bolt, specific nut, a specific auxiliary system, which costs us more higher, and that is also. But then if that thing is standardized in the local manner, it is much more cheaper than bringing it some from the above. So that kind of connection between the MSME is required. So that we are trying to provide that particular part. Consultation and in the universities, since we were in the outreach program, we were able to see that the youth are very much interested. We have conducted workshops with schools, universities, and the professionals who are working in the other some parts of nuclear where detection is required, detectors and other instruments which were there. We have worked. They are very much interested in having nuclear as to be the more as a in a bigger number. But then that is what we have found, that the youth is interested. A proper guidance or thing is required. For example, consider in US there are research reactors easily approachable to the students. Why can't we have that particular part? Because when people see, understand better, then similar kind of concepts can be actually been adopted in our country, so that people can have hands-on experience again, a look into the future what can become, so that new technologies, new ideas can emerge, and that can be finally be converted into the product as per the industrial requirement. As taking example, as Samal sir for NTPC said that the land requirement is less, or can as a sir also found out, the captive plants can use it for that. What if I design a reactor that can be having an industry-owned design reactor only, which have the safety measures in place? That can be done, but then that is the final requirement. So those technologies will actually require a bit of an open mind and a research and development team with from all the all from students and youngsters, rather than only a particular organization doing so. So that would require, that is what youth wants. New technologies can be developed. They have the ideas, but needs to be cultivated in a particular manner, in a fashion, or that has to be streamlined with the interest, so that that can be very easily been adopted. So similar institutional, universities and those should also be roped in for the skilled, skilled labor. We can say the skilled experts, so that they can have. So, and the technology development similarly. Let's look at some solutions. What we hope we will be able to provide are expertise. Consider that the expertise are majorly with, for the nuclear are with atomic energy now currently, Department of Atomic Energies, and I must say that they are more or less aged people, so that their knowledge needs to be transferred to the youth in a very easy fashion and in a very faster manner, so that the workshops, that has to be done so that the youth can take the lead in the coming year. The people should be, supervising should be there, but then that technology, their experience, their knowledge needs to be actually be generated in the youths very fast. Similarly, bridging the gaps between the experts and the youths is paramount. So we are willing to bridge that gap between those DAE and non-DAE institutions. So collaborations with DAE in other institutions, basically by training, workshops, and providing a pool of experts if required in the for example, if there is something kind of a disaster management group, or critical analysis is being done, probability safety analysis, and all those ones. For example, if there is a design which is coming up, so that those require some consultations, like the safety analysis is to be done, some simulations needs to be done. So basically a platform where that can be analyzed by because a pool of experts there and streamlined, so that the technology, if there is a good technology, then it can be be adopted easily, that platform needs to be provided. So be it DAE or non-DAE, that transition needs to be basically a platform needs to be provided that the transition from DAE to non-DAE organization can also be made in a very smoother manner. So then similarly for majority deployment, or we can say that the large scale nuclear reactors cannot be have an integral, or that parts there's an integral industry where components needs to be assembled, they have to be assembled on locations and that particular formats. So similarly that can that be multiplied in can that be parallelized, have an assembly stations where that been manufactured in parallels and in that format, so that it is very much easier and readily available. As sir said, as the experts here are also recognizing that the job of 700 megawatt will be done by 700 megawatt itself. Where 700 cannot be used, we are using SMRs. But then the early deployment of 700, can it be possible? Can that be done in a very rapid manner? That a construction time can be reduced, or the having the local vendors or MSMEs involved, can it be done in much more easier format or a cheaper format? So that needs to be done. And for SMRs, we can say that the number of, since we know this, if SMRs in the restricted environment, SMRs might be higher. SMRs, micro reactors, the requirement will be very much higher. So can that be done in a parallel processing format, so that a streamlined assembly line can be set up, so that as I said, currently we can say that only we can make 10 in a year. Can that be multiplied to 50 in a year with this, using these kind of formats? So that particular platform we are trying to provide that particular format as well. So, consultations similarly, as yesterday someone was mentioning that there are some problems with procurement, there are changing design, so that requires manufacturing problems are also there. Approving and licensing procedures, there are very limited opportunities if that is possible. So that kind of requirement, can it be smoothened out, having one consulting firm, so that the part where the basic scrutiny can be done very easily, and the new technologies can be deployed and developed in a faster manner. Since it is it's a kind of a revolutionary racing age, we can say that we want the results output as fast as possible. So with all the safety measures in place, can this be achieved using a different particular platform? So or basically having all the connections together, localized, having multiple sources put together. So that is what we are trying here. And just said, as Samal sir here has said that the applications should not be just power. That has to be there. The reactor, the technology has to be adopted as per the requirement and as per the conditions. For example, we know hydrogen is required. Can I set up particular number of reactors just for hydrogen production to meet? As Nayak sir has mentioned that if net zero condition is there, we will require almost 520 million tons of hydrogen. And if I'm not wrong, 1 megawatt will produce almost approximately 500 kgs of hydrogen, green hydrogen. So that means if we look at the requirement, that number is also higher. Can we dedicate specific reactors only for hydrogen? That will maximize our efficiency, not to shift loads. Where load following is required, we will do so. Desalination will become a different problem altogether. Can we have a dedicated one who can have a desalination problems, industrial heating? So those now, rather than only power-based reactors, we need to have different application-based reactors. So the technology has to be adopted and changed accordingly as per the industrial requirements. Not so can we have a different technology which fits into the regulatory criteria as well as the industrial criteria, meeting both them together. Those changes needs to be that technology needs to be thought of. So the youth needs to be come up with the new ideas, new technology, new development, so that both the criteria are met and provide basically designs. Consider a case. I was just giving example. Examples of occurrences of floods have increased. If that happens, there is an immediate need for a power source in that particular affected areas, at least to run the emergency systems. Can I have a source that can be transported to that particular locations until my other power sources are restored? At least emergency systems like power hospitals are to be operated. Can that technology, for my hope is that a micro reactor can solve that problem. Can that be developed in the coming future and with the development? I know we are still talking of small modular reactors and I'm talking about micro reactors, but then that is not further down the line. If I may be blunt, we are still looking towards the only the stage one of our power program. So that has to, all the stages for the reactors should also be rapidly been we have to capture that also. So that thing needs to be also been thought of. So that is what we are aiming. So I'll just change here one thing. We said that we might be the hoping to be the first organization that will be working on the micro reactor parts, because the generation 4 reactors are basically involving much more safer as per the regulations, and much more reactors. So that is what we are trying to do. So, and the design will be launched in January. We'll be giving up all the factors in January. And as the requirements are there, we'll be involving regulatory people all together from the conceptual design phase, preliminary design phase, and final design review as well. So that licensing and will be a very in this smoother manner, faster manner, and can be deployed in the future. So that is what I think will be the future. So all the details will we'll be announcing by January 2023. So thank you.
Thank you, Shyamak, for your elaborate address and coming out with the expectations of youth in India about nuclear power. Now, with this address, now we are moving to our first panel discussion of the day. And the panel is on, does India require decentralization of nuclear power? Can SMRs and wider adoption of nuclear power in core industry sectors lead this? And for this panel discussion, I mean, it will be covering many issues, very complicated, of course, from policy, legal, technical, and many other aspects, quite complex. But we have a very eminent panel for this, to basically debate and discuss these issues and come to some conclusion how it can be taken forward. And with us we have Mr. Sunil Ganju, Head Institutional Collaboration and Program Division, Department of Atomic Energy. Sir, please welcome, sir. We have Dr. N.K. Maheshwari, Head Advanced Reactor Division, Bhabha Atomic Research Center. We have with us Mr. Sushil Agarkar, Executive Senior Vice President, Godrej in Boise, to discuss on these issues. Sir, please. Request your presence. Mr. Samal, please, if you can join the panel. Dr. K. Maheshwari, I think he couldn't make it. Okay, no issues. Yeah, and sorry to introduce our moderator, Dr. Kali Ranjan Sivagnama, Senior Vice President, System Stop. Sir, welcome for the moderator role. Take it. So I will welcome all the panelists, eminent panelists on the dais, and our moderator, Dr. S. Kali Ranjan. So, Dr. Kali Ranjan, to you. You may please proceed.
Thank you. Hello. Thank you, Vinay. Good morning, everyone. The topic for today panel discussion is, does India require decentralization of nuclear power? Can SMRs and wider adoption of nuclear power in core industrial sectors lead this? It's a really interesting topic. After having two sessions I would say, a deeper sense of thought-revoking sessions leading to this particular topic is very relevant as of now. And some seeds have been thrown by the earlier speakers for thinking of this decentralization, because today the nuclear industry is under Department of Atomic Energy all alone. I just want to, before starting the panel discussion with the eminent speakers here, we have, one from the DAE family, one from NTPC, one from manufacturing sector, and I think we have a right kind of mix of people on the panel to discuss on this subject. If we look at the development of nuclear for the last 5 to 6 decades in India, and if you look at the other energy sources growth, like thermal or renewable energy, where do we stand today? When I joined, of course, I am from the nuclear background. When I joined nuclear industry way back in 88, 89, we were told that we are going to generate 10,000 megawatt by 2000. And then the target shifted to 20,000 megawatt by 2020. And today we are in 2022, and we are generating only, installed capacity of 6,900 around. So the growth has been very, 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 very slow. Whereas if you look at the last 5 years growth of other energy sources, the renewable source, especially solar, has grown by 312% in the last 5 years. 312%. And in the last 5 years, we could not add even a single unit to the grid from the nuclear sector in India. And Government of India has already planned growth for all the energy sector. And if I look at that growth plan, by 2030, the solar has to add 200 gigawatt to the present capacity of 100 gigawatt to going up to 300 gigawatt. And wind is going to be adding another 100 gigawatt. And hydrogen was talked about, and hydrogen is going to add 60 gigawatt. But what is projected for nuclear industry? From 6 gigawatt, we are going to reach 18 gigawatt. So are we really on the right track of meeting the energy demand? Today, we are at more than 4 lakh megawatt of generating capacity in India, which is going to be 8 lakh megawatt by 2030. That is the target of Government of India. Maybe from the 2% contribution, we may go to 3% contribution if this happens. The nuclear contribution may reach to 3,000, provided we reach that 18 gigawatt by 2030. Are we on track? Certainly a big question to be answered. So with this small background, I leave it to the panel now with a question. Do we feel this decentralization is necessary at this juncture? And if yes, is it really possible in view of the high capital investment and the long gestation period what nuclear industry takes into? So may I ask Mr. Sunil to start?
Yeah, thank you. It's a very potent question, I will say. The thought process in this regard has just started within the country, not only within the nuclear fraternity, I will say, but even in the non-nuclear fraternity. It's a tough call, but I think that is the way forward. The way we are talking of the nuclear capacity addition, and perhaps nuclear being the only way which can add to our clean energy initiatives and our clean initiative targets, which have been announced at various international forums. For example, in the COP26 Sharm el-Sheikh declarations, the talk of achieving clean energy through nuclear has been very prominently focused upon. And there is a thought process which has got started. We need to work on that. Yes, there are a couple of challenges, which I think this session, it is coming at a time where the previous speakers have already thrown up those challenges, particularly the presentation by our youth. In fact, I was hoping that we'll be able to touch upon those topics and we'll be perhaps the horse which will drive the bullock cart. But what has happened, the bullock cart has been put before the horse in the previous sessions. But then these are points which we really need to ponder. Yes, it is really possible, but then there is many elements which we perhaps need to address. Industrial upscaling is one of the things. Is the industry ready to really take the challenge? That is one thing. We may be talking industry, I don't mean the very big players. I will also, this may have to be taken up to the smaller sectors, where when we talk of smaller capacity addition, the assembly line production by smaller MSMEs or maybe the smaller sector, they will have a major role. The bigger industry partners, we have a few panelists here, they will definitely do their bit. But then how do we rope in the smaller capacity builders in terms of industry? That will be one part. The human resource or the skill development, multiplication of that skill development across all the sectors of manufacturing, quality control, safety, everything needs to be taken care. And there, of course, we have the regulatory aspects, the legislative aspects. I just wanted to add one more point. Mr. Samal in his presentation, he mentioned about NTPC, the nuclear getting merged into the safety standards of NTPC. I will like to put it in the reverse order. The safety standards being adopted by the conventional thermal power plants need to be uplifted to the nuclear standards. So that is going to be a big challenge. So those points we'll really need to think hard. Yes, there is a direction, there is a thought, not only within the government, but even in our department, within NITI Aayog, within the various policy making bodies. And we hope that yes, it can come in. Maybe if not very soon, but in the near short term, it should be possible. Thank you.
So if I can ask Samal sir, so see, with the background of all these things is HR issues and all these things are going to follow later. But to start with the thinking of, decentralization, do we feel some policy changes or, from the government of India or the mindset change in the nuclear industry has to happen? What is your view?
Okay. I refer to this tagline of NPCIL, atoms in the service of nation. So now it's the time really literally to do it, to put these atoms into service of the nation. As far as your question is concerned, whether any change in regulations, policies is required, definitely yes. First of all, the change in mindset is required. Now it has already happened. If you see, a lot of activities is going on. In last week, we had a symposium led by DAE and NITI Aayog in this directions, and I should say Dr. Naik in DAE is already working on the changing policies, changing the law. You see, as far as decentralization is concerned, is the call of the day. But we have to be careful. As you said, this has a dual use purpose. So for that, development doesn't happen overnight. It takes time, and you need resources also. When I say resources, as my previous speaker pointed out, you need manpower, trained manpower, not only manpower, trained, qualified manpower. And it is a capital intensive industry and need capital also. You need space also. All those things, resources are required. If you suddenly open it, 100%. Now it is it's a very closed door affair. As of now, it is a closed door affair. Definitely, you have to break the cycles, but in steps. Otherwise, what will happen, you don't know. Definitely, you don't know. So you have to go in steps. And definitely, there required some policy changes. First of all, mindset change, I already said, and then the policies.
Thank you. Thank you very much. Mr. Sushil, Godrej has been, involved in nuclear manufacturing for a quite long time. But with this kind of thought, which is coming in the market, like decentralizing the nuclear industry, how the manufacturing sector will, reflect on this?
Okay. So first of all, we need to ask a question why it was centralized in the first place. So everything was centralized in the beginning of independence. Even the car manufacturing, scooter manufacturing, and many of us would know that there is always a dictum from the government, and then it was slowly decentralized. And after decentralization, now we know the effects are tremendous. The growth is exponential, and the people can ride along, and there is no longer a wait. And youth of today, cannot even imagine that people in earlier days or my father's days used to wait for a scooter for 15 years or something like that. So similarly, decentralization will have its effect, and SMR requires, in my opinion, some kind of a decentralization because it has to go. So I'll draw a parallel to like Auto Hub. So that youth nuclear society, they have also mentioned that we require manpower, and DA is also mentioned that you require kind of a trained manpower, and how do we do it? So how does a auto industry is a good example, though it is not exact parallel, that how do they do it? How do they involve medium, micro, or small industries together? And you require much lesser manpower, much lesser regulation when you are at a one place together. So many industries, it is not only Godrej where I work for, but I can speak for many other industries, bigger, smaller, let it be L&T, MTR, and there are Walchan Nagar, and there are many industries who are keen to go into nuclear production. But today, what has happened that let's say NPCIL has a 700 megawatt program, and there is really a very limited manpower, and it is distributed all over India. So if anybody has to have a supply chain, then supply chain is also very randomly distributed. So decentralization is required along with the hub, sort of a auto type of hub, with nuclear manufacturing hub, where people can come together, smaller industries come together, no issue of logistic, and all those things can happen. Second, also very important thing, that why it has not been decentralized so far, in my opinion, that nuclear has a something danger attached to it earlier, and we have seen, the world has seen two phenomena like Chernobyl earlier and Fukushima very recently in Japan, and then NPCIL and entire DA, they went back to check their own safety procedures. So this also entails that human as a nature cannot fathom all the problems or all the possible you know what you can say, the calamities that can come, and nuclear can have a very devastating impact through the generations. So we need to be very safe. So entire, not only design, but the entire manufacturing has to be by a very trained manpower, and there has to be a lot of quality control and safety aspects to be looked into. The installation part is different. So today, if you see, most of the nuclear sites, there are EPC contractors, and there are so many industries, not only big, but even small industries, medium type of industries. Everyone is involved in manufacturing, installation, electrical controls, and everything. So it is possible. So in my opinion, decentralization can bring a very exponential growth, provided we look at the safety, the designs are proven. And of course, today, I know that India has manufactured smaller nuclear reactors for a non-civil program, I can say. But so technology is, it is not that technology is not here, and industry is also part of it. It can be done, and it can be done in a kind of a hub way, where you can produce at a very, very large scale. And we have seen, when there is a, it's again a very not a very relevant example, but I'll see how the humankind have put together to the requirement which has come suddenly. For example, it was a COVID, and vaccination normally used to take 7 years, 8 years, 10 years maybe, and all over the world, everybody, when there was a kind of a a huge requirement, many industries, government put their heads and hands together to come up with a vaccine. And virtually we are now out of. Otherwise, this conference would not have been possible. In the similar manner, the climate change is absolutely a very dangerous thing, and we need to control within 1.5 or 2 degrees. I really don't know, but if that is a change that humankind is required, in my opinion, most of the world and including India, this decentralization will definitely help, and it will have exponential growth. Thank you.
Thank you. Thank you. But there is another dimension to this decentralization. Like historically, if you see the growth of nuclear power plant establishment, from the site selection to the generation of power, it occupies almost 1.5 to 2 decades. Okay. Whether the investors today, when we talk about decentralization, I mean, we are also talking about investment by various players other than DAE or other than NPCIL into the industry. If I take that as a crux of the discussion today, will there be players interested to invest in this particular field when they have seen that in the past history, it takes more than 1.5 or 2 decades to see the returns on the investment? Is that really possible? Mr. Samal, what is your opinion? Because you are going to invest in now nuclear field.
Yeah, definitely it is possible. People will come forward for this investment. They say, as we have already discussed, we need the change of mindset. Okay, in previous occasions, there are some limitations. There are many restrictions, limitations, all those things are there. But you have to change the mindset. Definitely, you see, if you go to a non-nuclear sector, there are large capacity projects. They are also under executions. We are talking about, let's say, for a nuclear power plant, if you say the investment is similarly in these 6 years, 7 years, like this. If you go to a thermal power plants, in the same order, maybe 1 or 2 years earlier than that. We take about, let's say, 4 years for the conceiving the gestation period. Here it may be 7 years, something like that. And not that this will not give you returns. As I said, there is a misconception that this nuclear power is costlier than the others. If you the requirement of the time is nuclear power. Without that, you see, climate change. We are talking about climate change. Without that, you cannot have this retardation in climate change. Now, either you live or you don't. You live without power, or you live with power and have something. Yeah. So you have to have a balance. Definitely, in my opinion, a lot of investments are going to come, and the world is changing. Not only India, the world is changing. So definitely yes.
Thank you, Mr. Sunil. I think in 2020, when Government of India announced infrastructure pipeline, along with that, they also announced some decentralization initiatives on nuclear. Small size research reactors can be privatized, where the private players can join hands with DAE to develop research reactors to produce radioisotopes. What is the status? And as far as my information goes, that there are no players coming forward with interest. Is that correct, or what is the status now? And if that is so, how are we going to? How can we inculcate that interest for the investment?
Okay. Well, it's not really that there are no takers for the this what we call the isotope research reactor in the PPP mode. The model has been finalized. There have already been discussions with a consortium of industry partners. By industry, I mean primarily the pharmaceutical industry, because that is the industry which is going to be benefited from this isotope reactor. It is going to be in the public domain for the purpose of augmenting our healthcare infrastructure by use of radioisotopes. And it's not really correct that there are no takers. Yes, there are some what we can say legislative issues which have been already to some extent sort of classified. There may be some changes, but then the model which is developed there is basically the owner still remains the department. The department is still the owner. The processing of the products from the reactor goes into the private sector. But what we are talking here now is decentralization from, let's say, ground zero. You make the reactor, you produce power, you sell the power the way the US or many other Western world countries followed a path. So it may not be a direct comparison to think that, okay, the isotope reactor has not taken up, because it's again an R&D project. It's more into the research and development domain rather than industrial scale application in the initial phase. So that differentiation has to be very much there. And I just wanted to add one more point. See, when we talk of the industry coming forward to invest over a time span of, let's say, 20 years or whatever has been happening in the past, there is always a concept of the technology readiness level. So if the technology readiness level is at a fairly matured stage, let us say TRL 6 or TRL 7, what we talk about, there is no question that the industry will not come forward. Another point which I like to add here, of course, it's not directly pertaining to your question, but in a way it has a linkage. See, the renewable energy sector was decentralized. It's already well known. So we all tend to think that the nuclear sector can be decentralized in a similar manner. We have to bear in mind that it cannot be the same way. Renewable energy, when it was upscaled or it was decentralized, the tools for doing that were something which were off the shelf. You just buy the thing, get the land, put it, and just forget it. Nuclear does not work in that manner. So the safety concerns, the industrial readiness, standards, everything has to come. So there always will be some hand holding which will be required to take the whole process further. So it will happen, but then there will be some maybe speed breakers, we can say, in the short term. That's what I like to.
Thank you. Thank you for touching upon the area which I'm going to ask next to Mr. Sushil. When we talk about decentralization and scaling up the capacity in India, certainly the supply chain plays a major role. If you look at the infrastructure development, the EPC industry has scaled up their level to match with the infrastructure development. But when it comes to nuclear, with all the safety restrictions and regulations, following regulations, is the manufacturing industry capable of raising their level to match with the kind of expectations of the society which has been projected just now in the short span of another 2 decades?
Okay, to give a very short answer, manufacturing industry is capable. But you have to also look at what is happening now. Everyone here knows that India is the third largest defense what you can say spender. Now there are 3 industries which probably will require. There are 3 sectors which will probably require similar, if not exactly like nuclear, manufacturing acumen, I can say. One is defense, second is space, and the third is nuclear. Now, which is easier? Defense is easier. Space is relatively easier, though it has its own implication. Nuclear is more difficult. So manufacturing industry and any industry for that matter, exists for at least decent profit, if not phenomenal profits, and lesser headaches. Okay, so with nuclear, so far it has been a lot of regulations and for right reasons also. Whereas space and defense, they are relatively easier, require similar kind of infrastructure, similar kind of a trained manpower, and still you can get a decent return at a very reasonable time frame, you can say. Whereas nuclear will require a lot of training, lot of retention, and what has been the problem with the industry is discontinuity. Now all these years, see, nuclear programs, it may require 6-7 years probably to erect a nuclear reactor, and manufacturing, which is not an EPC, but all the primary or secondary circuit manufacturing equipment manufacturers, they do not have continuity. it is always you do something, train people, and there is a gap of 3-4 years, and again. So how industry would retain these extra high skilled people at an extra high pay scale and etc. But now the scene is changing. Now there is a fleet order. Now there is a huge demand. So now industry can keep people they have trained, and they can have a decent return, in my opinion. And investment, in my opinion, is not a problem, because also the government is supporting. So we have seen huge developments or huge investments taking place in other two sectors which I mentioned. So I don't think industry will be shy or not investing in this, as long as there is a continuity of operation. In my opinion, this also will be a good time. I can say a sunshine time for industry in nuclear sector to go ahead, so it can invest. Other aspect which I will touch on, the solar and wind. Now in a wind, there have been lot of what you can say runaway depreciation granted, and many, even film industry also invested in that. The biggest problem in India probably is a land acquisition and surrounding. So the bigger nuclear plants will require a huge problem. It will have huge problem. Wherever you want, the opposition will say it is not correct, and something will happen, and that program gets stalled. Whereas SMR, in my opinion, requires much shorter, much smaller area. Only thing is that safety aspects must be looked into. Then there is a decentralization, not if not to the private industry, but with the with the central government to the state governments. Also, that can be looked upon, and they can play a larger role. And whereas the land acquisition and land problems could be much easier to handle than the bigger nuclear plants. For example, probably Mumbai is around 3,000 megawatt requirement, it is 3 gigawatt, and SMR, if I say 100 to 300, I don't know 300 really possible, but let's say 100, then 300 kind of SMR, and still it is a mega city. If you go to much smaller city, then there's much smaller requirement of SMR and can be handled at a local level without really, a distribution network to that extent, to the entire grid. Maybe there are some, I am not aware of the grid things, but this can happen. So in my opinion, industry is ready, provided that there is a continuity, and I think that there will be a continuity. Thank you.
Thank you. Thank you. I think audience, yeah. I'll just conclude here and then move. We'll open to the pub. 1 minute. We'll open to the public questioning after one more round. I'll come to that. So the panel feels that decentralization is inevitable as of now, but it has to be planned in a proper way, maintaining this regulatory requirements, safety requirements of the nuclear industry. Whatever way the decentralization has happened in the renewable industry cannot be directly applicable to nuclear industry, which is very well understood. Now this leads our discussion to the next level, like SMR. We all know that anything less than 300 megawatt comes under the category of small modular reactors. But when I say SMR, it is not only small reactors, small modular reactors. And that means the entire technology of design is going to be reconstituted into a modular thought. You convert your construction, you convert your design into a modular design. That means whatever Mr. Samal has said, the mindset of the designer is also going to be changed. And today, as all we know, that across the globe, not even a single SMR is in operation and proven. The technology is not proven. There are many SMR players from US or Russia or France. Everybody is having their own models. And even micro reactors are there. I was going through one article where Westinghouse has given some 3 megawatt, 4 megawatt reactors, which is just mounted on the truck. So one of my colleagues was telling that if this is proven technology, and all the construction sites can have instead of a DG, this can be added. So that is another way of thinking when we talk about micro reactors, which is less than 10 megawatt. So there are a lot of things are coming up, the technology innovation. How are we placed in India with respect to the technology innovation and changing the mindset of our design into modular design? Mr. Sunil.
Yeah, I think the work has just started. In the last, let me say, one and a half year or so, the department and the government both have been sensitized to this issue. All the problems which we have been discussing, the land acquisition or placing larger reactors, that is how the thought process has initiated. But I'll say it is a work in progress. But definitely, all the options are being looked at. It's not only that we are trying to have some foreign collaboration and bringing in some foreign technology to have a quicker solution, but even the indigenous R&D, which has really picked up, and I am very positive and optimistic that in the next couple of years, maybe 4 or 5 years down the line, we should be having an indigenous reactor, which definitely will be a big boost to our Indian fraternity. We call it the Make in India concept, the Atmanirbhar Bharat concept, whatever way we call it. But that is the way the department and the government, I'll try to talk in those lines, is trying to move ahead. Yes, things are being worked out. There is a lot of brainstorming happening on this aspect. And there have been some conclusions, maybe from today's discussions and the discussions of yesterday. There will again be some sort of thoughts which will just filter out, and it can be reached out to the policymakers. So we do hope, we are positive in that. Another point which I was just again thinking when we were talking about this is the public perception. Mindset within the professionals is one aspect. The public perception about nuclear also needs to be addressed in parallel. It's not that it has to go serially. Our younger colleagues have already addressed that. So that also, the skill development, the technology upscaling, industrial upscaling, and the human resource, besides the public perception, have to be taken all at together. If we lay the seeds today, maybe down the line we'll be able to have a good fruitful tree in some time. But yes, I'll just add one line because it's my favorite quote from a poem I used to have in our childhood days. It's a few lines from Robert Frost. The woods are lovely, dark and deep, but I have promises to keep and miles to go before I sleep. So that is the crux with which we have to approach the whole thing.
Thank you. Thank you. Nice words. Can I ask Mr. Sushil to say your last observation on this particular topic of SMR, which is modularizing the design, and the manufacturing happens in a modularized way. We are moving into plug and play model. How do you visualize that?
I think I will give a short answer because DAE and NPCIL and BRC, they are better placed to answer on this. But I'll tell you this, that earlier the designs were made and then industry was part of it. In this time, SMR design, while it is being evolved or at whatever stage, industry is involved. So right from the beginning, we are part of it. And I'm aware that not only us, Godrej, but there are many other industries who are involved. Their inputs are taken, and simultaneously we have also been, in a way, preparing ourselves for this kind in coming, let's say 3 to 4 to 5 years, that whatever infrastructure that is needed, it can be built into it. How the modular things will work, which are the capex what may be required, and we are also given design input. So this is happening, hand in hand with the scientists of BRC and other people, and of course DI support. So that's
Mr. Samal, you are venturing into this SMR. From your presentation, we could see that you are deeply, thinking about how it can be integrated into thermal industry. So, with this kind of design mindset, how NTPC is, placing itself in the market of SMR?
Yeah, you asked about this modular concept. Why this modular concept is required and why it came into being. If you go to just 2 minutes back, you asked about the larger gestation period, coming investment and all those things. One of the reasons why this modular concept came is to reduce this gestation period. If you standardize the equipments, components, and modularize these components, then you can drastically reduce this gestation period so that more and more investors can come. You can get return very fast, and you can you get the electricity maybe in 2 years or 3 years instead of waiting 10 years. I go one step further. I see in future It's a nuclear battery. You put this battery, purchase this battery, use it, and after the useful life, the supplier comes and takes it away and recharge it, and then again supply to you. So that is the future I see. I don't know whether this is a daydream, I don't know, but that is the future I can imagine, sort of things.
Thank you. Thank you. I think the panel has put on so many aspects for the audience to think. Now the forum is open to the audience before we conclude. Can you pass on the mics, please? You can ask your question and pointedly to the right, no, particular panelist.
I am happy that the panel talked a lot about safety. I want to bring in one more dimension. The nuclear utility people all over the world have a global responsibility. If you see the graph of growth of nuclear, after each accident, it has come down. The accident, in fact, I yesterday told accident anywhere is accident everywhere. Not safety-wise, not geographically, but public acceptance-wise. So you have a universal or global responsibility. In fact, I coined a word, something higher than safety culture. Safety as a value of a company. In fact, I can explain what it is, but there is no time now. So I think he mentioned about uplifting the safety from thermal to this is very important, because you're not only working for yourself, you're working for the whole world actually. And with the innovations coming in, with so many African countries, new countries coming in, it should not be that, oh, developing countries cannot run things safely or something like that. Thank you.
So thank you very much. This was a very good discussion. So I'll be talking as a regulator, not much, but as a nuclear scientist, I have something to say. So initially, safety much has been talked about, and the regulations also. They're required, but one aspect which was missing, my colleague has brought out, the security aspect, which was also discussed. So the structure which we have in US of A is totally different from what kind of safety culture or what kind of DA and BRC they are following the security culture. AERB is also involved. So these security aspect also need to be taken care. So there the regulator is sitting at the top of the nuclear organization, and they are controlling everything. And it is possible, but when it comes to Indian condition, I think rethinking is required, how the security aspect will be taken care. Safety definitely cannot be compromised, that we had already discussed. So I'll remove the regulator's hat now. So we are talking about growth, deployment, quick deployment, which is very important. And SMR have flexibility, have many applications, can be modular, and that is a good aspect. But it complicates the safety also. But those things can be taken care. Once it comes, submissions come to the regulators, they can see, and the things can be sorted out. There's nothing like which is impossible. But the bigger question is investment. How we motivate the investors. So, what kind of arrangement for finance we are looking at? Are we looking it from the government, or we are looking it from private industry, and the returns which was discussed? So, how we can get the returns very quickly? So, I just recollected something about this fossil fuels, petrol bonds were there. So they're giving very handsome returns. That's how we see the petrol prices are going up. So if energy is our requirement, electricity is our requirement, and quick returns are required, then bonds can be considered. Maybe the petrol bonds were cornered by some people who were knowing that in the future they are going to give us handsome return. But many people are aware, and even the common people can come forward and buy these bonds. Can we motivate them? Or this kind of model is going to work? So the panel can comment on this. Thank you.
Anybody?
You talked about money or for investment. I think as the industry or the sector opens, there are channels available. So nuclear, any industry would have access to public money, that is IPOs or can collect, and that's a huge money. And if there are decent returns, then people will invest at large. So not only industry also have lot of people backing the industry in a long term returnable venture. And in nuclear, in my opinion, like defense, as we have seen, there was spurt of IPOs which flourished, and there are many industries have come. And nuclear has a long term potential. And so one is, you can say, government funding, industry's own funding, and also the public backing of this. And as you very rightly mentioned, that if the public opinion is for the cleaner energy and nuclear energy, and they see nuclear energy as a safe energy solution, then in my opinion there is no problem with the fund flow, even for the private investors as well.
Yes, but it is not happening very quickly. These things should happen now. We have only a few years. Within that, this kind of funding should start flowing in. That is the major issue. It should start flowing. That investment should start flowing. How to motivate the investor, whether government or private, hardly matters, or the public.
I'll just add one quick dimension to this debate or discussion. When the solar or the renewable energy sector was being ramped up within the country, we have seen a lot of policy intervention, incentivization of investments from the government. I think a similar thing needs to be done, is the need of the hour for nuclear. Low cost financing is going to be the prime mover for not only changing the public perception. See, I remember around 10 years back, when the solar thing was being just mooted, nobody was really sure. You have these solar cells, photovoltaic, everybody was having a lot of apprehensions. But the moment government started pumping in some incentives, if not the money, the whole landscape has changed. Now, even though we realize that it was done with the aim of upscaling, but then what is happening down the line, that is being realized now. But still, a similar policy, in fact, if it can be adopted within the nuclear sector, and I think that has to be done, because there is really no other option right now. I'm not talking of SMR right now. I'm not talking of large nuclear power plants. I'm just talking of nuclear. Whether it is an SMR or a large nuclear power plant, the finance has to be at a low cost. We have seen this model in a smaller way, maybe not very directly, in our foreign collaborations for the reactors, the large reactors which we have. We have some sort of low cost financing from our foreign partners. So something like that has to be really built up, and it has to be sort of consolidated and then brought onto the table and taken forward.
Yes,
It's just a small.
this is possible from the government.
Yeah.
But
It requires a policy intervention.
right now
yes.
we have model of SPV. Maybe Samalji can explain on that. Whether this SPV kind of model which we are following for new entities in utilities in nuclear power, are they very slow, or they can pick up like what is required right now? Can these SPV kind of model work, or we need a different kind of financing which can come quickly?
Yeah, first of all, coming to government funding. Government funding is not a sustainable model. Maybe initial projects, 1 or 2 projects, you may expect government funding, but we are not talking about 1 or 2 projects. The scale we are talking about, we have to have a sustainable system. I fully agree. First of all, the policies should be conducive, like we did in case of solar and renewable energy. For example, I should say, why this nuclear cannot be declared as a green energy? To find to channel the green funds. Why we cannot do that? We have done it for other sectors like wind and solar. Number one. Number two, you said like SPV. SPV also one model. You can try on SPV model, public-private partnership also. Of course, yesterday we discussed about minority partnership from the private. I do not fully agree that private participation will increase the efficiency. I don't fully agree. There are a lot of public sectors, lot of government companies operating very efficiently, very fast, agility is there. That can be done. Of course, that may say funding. Funding can come from private without participation in the equity also. That is also possible. So many models are there. Now we have started thinking. Now we are trying to open up the sectors. Definitely, a lot of avenues will come forward. Lot of funding will come forward. Thank you.
Thank you very much.
I think the main question which is coming here is the funding. And if I recall, Dr. Kakotkar yesterday answered this question which we are trying to debate today. He had suggested that the operator or the owner of the plant enter into a long-term PPAs with the end user, and it will be consistent with the current legislation. It will be like not requiring too much of tinkering with law, etc., because that is what is possible. And once the investor sees that there is a return on investment, and anyway he is getting power, which he is able to sell to his persons at government controlled rates or whatever. So that is one. Second thing which I want to say is that decentralization of nuclear power, yes, definitely. I mean, probably right now, NPCIL and Bhavani are the only two persons which are doing the nuclear business. We have had JVs with NTPC, IOL, NALCO, etc. So the steps are being taken in that direction. And yesterday again it was pointed out that you should not, or the JV partners should not insist for majority stake. Let us jump into the water, learn swimming, and then as the time goes by, we will be able to do that. As far as the word modular is concerned, you see, SMR is small modular reactor. But modular right now also in NPCIL, the modular concepts are already there. And even elsewhere in the world, the modular concepts are there. Only thing is that we are talking small, 100 or 200 or 300 or something like that. And it was said that, oh, instead of so many sites, we will, we cannot have 40 sites for mega nuclear power projects. But you imagine, go to SMR, you will be multiplying these sites by that many number. So 700 twice. If you go to Jaitapur type of thing, enormous. And to my mind, as of today, the exclusion zone is same irrespective of the power level. So imagine where will public stay if there are so many reactors every place. So it is requiring a rethinking, as Dr. Naik has already said, that yes, DA is having a look on the exclusion zone also requirements, etc. And
I'll clarify you, sir.
Sir, give me 1 minute. Another thing which I want to add, that long time back, Nuclear Power Corporation had entered the market, not in the equity, but the debt market. And they had asked for non-convertible debentures, and there was a good response to that. And maybe once the public perception that nuclear can deliver, that kind of thing is built into the public confidence, and then NPCIL comes out with a, again, NCD issue. So maybe there will be a lot of subscription to that. Thank you.
Sir, it is not the question of the exclusion zone or getting number of sites. It was the question of utilizing the retired thermal power plants. When we are retiring so much thermal power plants, can I utilize that land? Already it is there. Can you imagine acquiring land for 40 sites as today's conditions? How many years you need for those? That infrastructure is already available with you, and I believe, as you said, exclusion zone and the requirement, the small modular reactor, the very purpose is to eliminating the emergency planning zones and all those things. Exclusion zone is there, whether it is 1 kilometer, whether it is a 500 meter or is the 600 meter, that is to be seen, that is to be debated, and the design will tell how much you need. So if you can, as I said, you don't need a site to fit my design. You need a design to fit my site. That is the whole aim of having because your SMR design is not freeze down, it is not there. You have to find a reactor which fits to my requirement, my site requirement. That is the main aim.
In view of the time constraint, I will have only one more question. I think they have raised the hands here, middle.
Sir, I had something to add here.
But I think only one more person we'll have. Other things we can have it offline.
I think it is a very lighter sense so that we can enjoy the coffee outside. SMR, I believe, because we are cricket fond country. Yesterday's cricket, if you look at, there were test matches, 5-day matches. We struggled to score 200 runs. Okay, and umpire also looks at it very comfortably. Then came the one-day international, and now it is 2020. I believe SMR is 2020 or micro reactors will be 2020. And the umpires are still there. Umpires are more stricter, that means regulators are more stricter, will be there. But it is a different game. You have to score the same 500 runs in 20 overs. So this is the mindset you have to change. And with regard to new entrants, similar thing. You look at test matches. If you look at new countries like Netherlands and all can never play, Afghanistan can never play, but they can play 2020 match. So same way is SMR and micro reactors. Thank you.
Thank you. I think time is running out. There are two people waiting for a long time. If I have to give chance, we have to give to everybody. I'm sorry. We'll have it offline. To conclude, the decentralization is the call of the day. There is no doubt about it. That is what all the panelists and all the audience here has understood. The only thing is, how do we do it? What are the policy changes we need to make? How, in a planned way, not sacrificing the safety and security of the nuclear system or nuclear industry, how we can plan it. In addition to that, there are few issues which I am just throwing open for the thought process of the audience here. One is the public acceptance, how are we going to face? And the second one is the manpower issue which has been discussed. How are we going to rope in all the academic institutions in taking up the research along with the DAE, not restricted to only few institutions, because the kind of manpower required to get into the research mode, to get into the operation mode is huge in number, the way we are looking at the exponential growth. So that is another area where all the nuclear players have to think of. The third one is, and the last one I would say, industry upskilling. There are few players who are working for the nuclear industry today. How we can make them in multiple numbers, how we can develop other players also in the market to develop equally capable safety, nuclear safety equipments in the market. Because I understand the supply chain plays a major role and manufacturing industry is going to play a very, very critical and crucial role in the development. So thank you panelists for your kind words and then very, very introspective opinions. And thank you participants and audience for having your views spelt out in a clear tone. Thank you very much.
Thank you very much, all the eminent panelists and Dr. Kali Ranjan for putting up relevant questions and having this interesting panel discussion here. Really wonderful to have everybody's participation.